Okay, so let's talk about our last concept here, and that is the alternating series test. Okay, so when we say alternating series, what we're talking about is alternates positive, negative, positive, negative. So like a series like this, 1 minus a half plus 1/3 minus 1/4 plus 1/5 minus dot, dot, dot. So notice I can write this series. Here's my nth term formula. So I could write it as -1 to the n plus 1 over n. There we go. So let's think about this series and what is it going to do. If we think about adding up all those terms, so I have 1, then I subtract a half, then I add 1/3, then I subtract 1/4. We can think about that like, so what if I started here at 0 and out here I had 1? So I do 1, and then I subtract off a half, and then I add on 1/3, and then I subtract off 1/4, and I add on 1/5, and I subtract off 1/6. So I end up sort of homing in on whatever L, whatever the limit of this series is, the total. And so this would be an alternating series. So what we're going to look at is series like this, and how do we know if they converge or diverge? So here is the alternating series test. It's a bunch of conditions. It says if you have some series, the sum as n goes from 1 to infinity of -1 to the n plus 1 times some nth term formula, u sub n is what your book calls it, which is really just like take u sub 1 and then subtract u sub 2, since u sub 2 would be negative, add u sub 3, that'd be positive, subtract u sub 4, that'd be negative, plus dot, dot, dot. You're going to know if something converges if you have 3 conditions that are met. Condition number 1, if each u sub n term is positive. So in other words, the -1 to the n plus 1 part of it is the only part that's making anything negative. By itself, each u sub n is just positive. So if I think about the one that we had up here, it'd be like I had -1 to the n plus 1 times 1 over n. So that the 1 over n would be my u sub n formula. So condition number 2. U sub n is greater than or equal to u sub n plus 1. So this is just saying the nth term is bigger than the n plus first term. So in other words, they're getting smaller and smaller and smaller, which makes sense. Here they put a little condition on it, and it says for all little n greater than capital N for some integer capital N, all they're saying is this. What if they don't start out that way, but eventually beyond some point that happens? Even that is enough to say this thing is going to converge. So not too many worries about this. They're saying if eventually that happens, the nth term is greater than or equal to the n plus first term, we're good. Condition number 3 is that the limit as n approaches infinity of u sub n is equal to 0. So let's take a look at an example. If we said, does the sum as n goes from 1 to infinity of -1 to the n plus 1 times 1 over n converge? Let's check that out with the alternating series test. So we really just check each one of those conditions. So condition number 1, so by itself is just the 1 over n, always positive. And it is. Check. Condition number 2 is 1 over n greater than or equal to 1 over n plus 1, and it always is. Here we didn't have to mess with that like beyond a certain point it is. It is right from the beginning. Check. Yep. There we go. That's true. Question number 3 we ask ourselves, is the limit as n approaches infinity of 1 over n equal to 0? Yes, it is. So we'll just take those 3 conditions and say, yep, converges, therefore converges by the alternating series test. So it's just 3 conditions that you've got to meet, and then you'll know that something converges. So that was our last test for convergence and divergence. Your book also puts together a handy little flow chart for trying to decide, like, how should I figure out if something converges or diverges, a different way of looking at all those tests that we've been doing. So if you check out in your book, it's on page 521, there's this flow chart that says, all right, what should you try first, second, third? So start with the nth term test. If you can, especially if you suspect something diverges, check out the nth term test. If something is equal to 0, if it's not equal to 0, you know the series diverges and you're done. If it's equal to 0, inconclusive, yes or maybe, go on to something else. Is it geometric? Geometric is really easy to figure out. All you got to look at is the R. If it's not geometric, is it a p-series? Again, really clear cut for figuring convergence or divergence. If it's not a p-series, then do one of the other things. We did ratio test, not really integral or nth root test. Those are things we didn't do. So check out the ratio test, or check out alternating series tests that we just did. So those are all the different ways that we can figure that out. So hopefully that flow chart helps you figure out, like, what should I do in each individual one. All right, so try out our last bunch of homework, and that does it.